Hello. um, Welcome to the third help session. It appears that no one's here yet, or there's no questions. So I'm just going to wait for 15 minutes and see if anyone has any questions. If you've got questions, put them in the chat. Else, there's not much I can do if people don't want anything answered. So why is that so big? So to ask your questions or to specify examples that you want to go through, you can go on the Hangout, which is usually easier because then I don't have to have both the screens open. Or you can put your question in the YouTube. So put your questions or whatever you want to go through in the chat. And I'll leave it there until we've got some questions. Also, the Hangout link is in the chat as well. I'll put another paste of that. This is being stupid. So, what would you like to cover? Let me know. I'll wait till there's questions because I'm not just going to ramble on. Okay. What's a good resource for practicing flow diagrams and box and pointer diagrams? So, flow diagrams, what I would recommend is just grabbing some of your code that you've already got or get an explanation of the code. So, for example, let me go back to one of the old labs. So let's do something easy to start with. Week 2 maybe, week 3. Okay. So for flow diagrams, maybe have a this one's not a very good example because it's not much flow. Everything just happens one after the other. Let me find a better example. It's probably too early. Week 3 is probably a good one. All right. So week 3, yeah, this is a good one. Here, we have a lot of information, and we actually have the flow diagram. So you can use that to see if, given what your reading of this, and if you can turn that into code, then you understand how to read a flow diagram. And if you can take what it says here and turn it into a flow diagram, then you understand what's happening in a flow diagram. So if we have a look at this second one, which is a little bit more complex, we have a bunch of steps here. So let's go through them and let's draw the flow diagram. You've got plenty of labs that you can use to practice your flow diagrams, and to test them, all you need to do is write the code to see if they make sense. So let's take this one. It's not going to work. I need to copy it. Just give me a second. Where's my paint? Select. Stupid thing. Okay, so we have that there. Oh, that's horrible. Why did I do that? Okay, we might just leave it like that. All right. So given this example, that's my thing here. All right. So given this example, we can see that it's all just one function, so we don't need to worry about our functions. In LMS, where are we? Sorry. 5, like 6, 6, no. 5, 4. Where is it? 7, maybe? Like 7. Cool. So in week 7, we have a bunch of all the different diagrams. I think there's also a lecture of them all as well, but this is a nice handy way to look at it. So the first thing we've got is our function entry, which is main. There's no arguments in this case. We're not using argc or argv, so we don't have to worry about that. So add the main function. I think I need a thinner pen. Let's go 3. Yeah, better. So the first one would be main. Then we have declare a bunch of variables. So this is just an operation. Now, as you know, you can either do this using code notation, or you can use just natural language. It's up to you which one you want to use. Either is fine on the exam. So here, I'm going to do this one using code and just write int hue, int saturation in, blah, 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 blah. I think you understand that. Then we've got more variables, so I might declare them as well. I'll separate these boxes. I can do a couple of things in some of these boxes if they're related, but I'd keep some of these different. Now, when we come across a function, so ask the user for a value. When we have a function, all we do is add these 2 lines. So this would be printf, asking the user for something, and then scanf something. Okay, because these are now functions asking the user, so we have to ask and we have to collect and store. And we do that for a whole bunch of times. So I'm just going to skip all those. Then we do some calculations. That's just an operation. So it's just another square, and we just explain it. Now, if statements, it's just a rectangle. So whenever we see an if temp is less than 0, we say yes. And then we get temp times equals -1. Else, no, and we do something else. Then calculate more calculations. All the calculation stuff are just going to be in squares. If, else if, we've got the if it's true. Then we've got another if statement. If it's false, and that's just an if, else if statement. And they'll just go to the next statement. So if it's false, if it's true, if it's true. So we can basically use any lab and create a flow diagram of it, and then create the code from it and see if it works. So that would be how I would practice your flow diagrams. The other way is taking some of the ones from the labs or taking ones from the assignment and see if they match and work. So you should be able to I don't know where I put that. Let's just grab that. So if we go into lab 3 and lab 4, I think it is. Once the labs start getting a little bit more complex, it may be a bit too difficult to put everything into flow diagrams, but for the most part, you should be able to do a lot of them with flow diagrams. So here's another one. This is lab 3, and you've got the flow diagrams there as they're being built. So you should be able to understand what this says and be able to go both ways. So there's quite a number of examples there. Practice, I would just go between code and back again, and with your steps, go forward, backwards, forward, backwards. And if it works and it matches the code, then it's fine. If it doesn't work, then there's a problem. But you also just need to pick out keywords. So if there's iteration, it's either a while loop or a for loop. If there's a condition, so if something or when something happens, then you know there's going to be an if statement. And then the rest pretty much are going to be squares, or they're going to be functions. Now in some of these earlier ones, the functions haven't been shown, but you should be using that. All right. In terms of box and pointer diagrams, they're really easy to test. I might actually give you a bunch of examples. So what I'll do right now, because there's not too many people, there's no questions on here. No, there isn't. Cool. All right, so what I'll do, because there isn't too many people, I will yeah, where did I put them? Oh, there are Unix. Sorry. Batch. Cool. Okay. So what I'm going to do is just quickly go through this and grab the good ones. 0, 1, 10, 100, 101, 102, 5, 6, 7, 8, 9. Wait, these aren't in order. Crap. Okay, that'll do for now anyway. All right, so what I'm going to do, I'm just going to give you 10 for now. I'm going to put them up on LMS. LMS. Okay. So I'm just going to put a folder up on LMS. I'll show you in a second. Turn everything up, and then we'll go through some. This is probably the easiest way to practice box and pointer diagrams because they're in a similar format that you would expect on the exam. And folder, cool. Okay. So I'm just uploading a bunch of files to LMS. So now if you go to somewhere, week 12, you should find a folder. Let me put it up on the screen. You should find a folder with all these files in it. So box and pointer practice programs. There was 500 generated, but some of them aren't successful and some of them are successful. I have to go through which ones are successful, but these ones should work from the report. So given these, just take one. That one's kind of boring, but some of them are a bit boring just because they are randomly generated. And that's way too big. So these are good because what you can do is draw your box and pointer diagrams and then check those actually equal what you think they should have equaled. So once you're done, you just copy the code into whatever editor you're using, compile and run it, and then you can check your simple variables to see have they changed value if you're expecting them to. Let me get a better example. That one's kind of boring. Here we go. This one's a lot better. Okay. So this one here is number 101. So I do use. It's still too big. Let's go down to 5. Let's make this. There we go. All right, cool. All right, so we have this example here. It is a bit squished up just so I could fit it on the page. So there's a bunch of examples like this now on LMS. They're all here. And they all print out the simple variable. So if you want to test it and see, do your box and pointer diagrams work, you can check by checking this number. Now, you still can make mistakes and you won't be able to see them, but generally what we're doing is trying to change whatever your original variables are. So most of the time you will. So we're changing this value here, this 17, to something else. And so you can test it. So what I would do is just go through this. So I've got main. Now, don't forget for each step, so the steps are quite big. So they're things like 4 variables at a time are declared, but you still need to show each step. So there's also the answers here on LMS for the one we did in week 12. If that ever opens, so you can see how you should lay out your answer. Okay. So that's all there on LMS. However, I'm going to be a little lazy. So in main, we have int a, and it's an int, and it's a value 17. We then have b, which is an int star, and it's pointing at the address of a. So I can see address of a, so I know exactly where this has to go. It has to go to the outside of a. Then we have int star c. So don't get confused about this. Because they're in a row, it is declaring this pointer. It's not dereferencing it. Okay? So if I have int star b, and then I have star c, this is equivalent to saying int star b, int star c. Okay? If you don't put the star there, then you're saying int star b and an int c. Okay? So just be careful about that when they're in a line. So we've got a new variable called c, which is auto type int star, and it's c. Now, this is something that sometimes catches people. This is taking the value of b. Okay, there's no address or a star in front of it, so it is just taking the value. So it is taking what is in here. Okay, it's the same thing as if we had that's a horrible color. If we had x equals 4, so int x equals 4, and then I have int y equals x. Okay, it doesn't point to x, it doesn't dereference x, it's grabbing the value 4 from x. Okay, just because it's a pointer doesn't make it any different. It is still just grabbing the value. Okay, so you look what's in here and you grab that same arrow. Okay, because you're grabbing the value. Now, as I showed you last week, you can think of this as a number instead. So you can go, this is A2, and this would hold A2. So when you say C becomes B, this would also hold A2. Okay, and that's why it points to this. Okay, if that makes it easier for you to think about, you're welcome to do that. Yeah. Then we get to this step. So we've got D becomes the address of C. So, oh, I forgot to declare D. Sorry. So we've got D, and then we've got int star star. And this points at the address of B. Okay. So we know because it's got the @ symbol, and we know this is legal because this is an int star, and this is an int star star. So int star star can point at an int star, and an int star, an int, and an int star 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 can point at an int star star. So if you're confused, make sure that you double check that. When you have a look at all these arrows, the thing that it's coming from to the thing that it's pointing at should have one less star. And we're not going to trick you. We're not going to put anything that's wrong. So if that has a star, then this can't have a star. If this has 2 stars, then what it points to has to have only 1. So we've got D points to the address of B. Q. Then we have B becomes the address of A. Now, we note that this is already holding the address of A. So it's just doing this again. It's not really changing the value. It's the same thing as doing something like int x equals 4, x equals 4. It's kind of pointless. Okay, but you should recognize that that's pointless. All right. So now we get to our function. So we have a bunch of functions, and we note that they're returning something as well. So our functions are in a different scope. So let's draw that scope, and we have func1. Now, the first thing that we want to see is everything on the right-hand side. So this right-hand side. So we go to func1, and it declares one variable called a. And it's an int. Now, we note that this a, and this a are two separate things. Okay, they're not the same. So now we take that and we pass the value of a into this variable. So we get 17. Okay, so that's the step after entering the function. So where it says entering the function, so for example here, this one here, this is the step right after entering the function. Okay, C. So we don't care about this a on the left-hand side yet. That's only when we return from the function. So entering the function, we don't worry about what's on the left-hand side of the expression. Okay, so now we're in our function, and then we set a to 2. Then we return a. So on after this return has been evaluated, all this is gone, and this is evaluated down to 2. So now we have the expression as a equals 2, okay? Because we had a equals func 1a, and our return value is 2, so now it's just a equals 2. Okay, and that's how you can think of returns. It just replaces everything with that number. So now, after we have 2 there. So that's the step directly after returning from the function. Okay. So now we have 2. Then, next function. So here we have, we're on this line here, and we look at the right-hand side first. So the first thing that happens is we declare this variable int b. So we've got int, we've got b, and we've got int, and in there we pass this value, the first argument. Okay, there's only one argument in each one of these, and this is just getting passed a normal value, -10. So we're not passing a variable, we're just passing a value. It's an int, so nothing changes, so that's fine, it's -10. Now, in the next line, we change this to a 9. And then we return from our function. So in that step, this 9 gets sent back, and the function is gone. So now we have a 9 in here. Then we have another function. So we have func3. So this function here creates another variable int c. We send the value -1. And that's straight after that step. Then we have the next step. So c equals 9. And then we return. Once again, we're saying a equals 9. Now it's already equal to 9, so kind of pointless. Now, at this stage, nothing else happens, so we print out the value. If you get something different than 9, when you print it out here using the program, then it means what you just did was wrong. You need to work backwards and find out where you're wrong. Okay. This example doesn't involve too many pointers and dereferencing. So you could make a mistake in one of these, but in some of the harder examples, randomized, so you have to find them, you should be able to see, is these values right? Are they correct? You can also go further and test your box and pointer diagrams by going printf. So if I wanted to test this one, I would add another printf if I was really unsure, and I would go printf address of A. Then I would use a pointer. Then I would say the value of B equals pointer. And then I would say the value of C equals pointer. We'll worry about that one later, D later. And then I would print out the address of A, the value in B, and the value in C. And why I do that, because if all three of these aren't equal, then my diagram is wrong. Because remember, the address of A is whatever, A2, let's say. It's not going to be A2, it's going to be something that your computer gives. But remember, this holds A2 and this holds A2 because it's pointing at that address. So all three of these values should be the same. So that's how I could test if this part was right. Now, if I wanted to test D to see if it was right, I might move some stuff around. I just deleted that. So if I want to test if D was right, I can go printf address of B equals a pointer, and then I'll grab D is a pointer. I'll probably put a new line as well, but I'm being lazy. And then I print out the value address B and D. And these two should be equal. And the reason being, let's say we give this address 10, then this holds address 10. So these two values should be equal. So you can tell if your box and pointer diagram is incorrect or correct or incorrect based on just using these printf statements. So even if the problem gets harder, you can just copy and paste and make a whole heap of these for all your variables. Grab all the addresses of your variables and see, do they add up? So I would just practice by getting some of these programs, trying them out. There's 10 there at the moment. I will add some more later. I was going to rewrite the program to make them a bit better, but I think it's a bit late now, so I might just chuck them all up. But you can test it. So I do it. I print it out, see if your A's right. If you're really unsure, try printing out the pointers and what they're pointing at, their address. So what I am doing, all I am doing is seeing if, so to test, I print out B because this is where it starts, and then I print out address of A because this is where it ends. Okay, and these two values should be equal. So the end of this has address A, the start of this is C. So address A and C should be equal. You could even go further and write a tester to test if they're equal, but that's up to you. And same here. So I'd go D, is that equal to address B? Because that's where it ends. Does that help? Maybe.
If you got more questions, put them in the chat. Cool. Also, just remember that the flow diagrams is about testing your problem-solving skills. So it is just about you reading a problem and being able to draw a solution. So it isn't, if you can't develop your problem-solving skills, then it's not too much to do with just there's always an answer and a way to go about it. Because the flow diagrams, there's not going to be one answer. So for the even the exam, there's multiple answers that could be the right answer. There's better answers and there's worse answers. So for example, let's say I had a problem. So give me a sec. Create a program that tells if a dog is big, medium, or small, where big is, well, where you are given its size as an int, and big is between what's it called, 0 and 10. That should be small, really. Medium is between 10 and 20. And actually, let's say 11 and 20. And big, anything between 21 and 30. So if we're given this problem, there's let's add one more thing. Anything else is invalid. So if we're given this problem, how you go about it, depending on how you problem solve, is going to be different. So you can still read that. Some people will take the approach of going, so let's say you get the size first. %D address. Why is the pen being stupid? Size. You get the size first. Now, it's not incorrect, nor correct, to check is it invalid first. So if size greater than 0 or size less than, less than, let's say, less than or equal to 30. Or greater or equal to 0. Then you do something else. You exit the program. Other people may test, is it between 0 and 10 first? Then is it between 11 and 20? Is it between 20 and 30? And then have an else statement and then say it's invalid. So the first example is this, where let's say this is the end of the program. And then you test all your conditions for your dogs here and then end the program. Where someone else may test all their conditions and then have an else statement which says it's invalid. So how you go about it is going to be very different. Another thing is how you go about this. So some people will pick up that, okay, if it's not between 0 and 10, and I know that it's already between 0 and 30, I don't actually need to check this 0. I just need to check if it's less than 10 because I've already checked that. Then I don't need, for my next test, I don't need to check is it less than 11 because I've already checked that because I know it's greater than 10. And then 21 and 30 have already been tested because I've done this. So there's always going to be multiple solutions to a problem. So the best solution would be eliminating that. And all you really need to check in this problem is this, this, and this. The 0, 11, 21, and 30 really don't matter here. And if you can pick that up, then your solution is slightly better and your problem solving better. Does that make sense? But it doesn't mean your solution is wrong. It's just not as efficient. All right, if there's any questions, raise them. Okay. So I'm assuming everyone's a bit overstudying at the moment, maybe because it's Friday night. So I guess this will be a pretty short session. Let me see when the next session is. So we'll do another session on Sunday. And the last one on Tuesday. Okay, Tuesday session may be really late. I may need to change the time for that. Okay. If there's no further questions, I might wrap it up there. All right. Thanks.